In this video, we are looking at the solution for this question. Assume that a noise channel intended to transmit symbols, say zeros 60% of the time and ones 40% of the time. At the receiver, there is a 1% chance of obtaining any particular symbol distorted. What is the probability of receiving a 1 irrespective of which symbol is transmitted? So we need to pick probabilities here. So we have, let's put what we are given. So let A be the event that, so let A be the event, that 1 and zeros is completed. B be the event that ones is completed. So then we are given that the probability of having A to transmit A, we get 0.6. The probability of having B transmitting 1 is 0.4. The question is, what is the probability of receiving a 1 and not transmitting 1? So you transmit, there's a possibility that you transmit A, it gets distorted, you end up receiving B. Okay? So you transmit A, and then the receiver will receive B. It's possible. So now we want to look at a separate probability from those. So now let's call it, just for example, the first one, I want to write it as, what could be the probability of 1 is received at the receiver, given that you have A. Okay, so 1 is received, so maybe I can say, okay, let X, or let's C be the event of 1 being received, of receiving 1. Yeah, but I write it like this. So have the probability C given A. So you receive 1 in an event that it was distorted. Okay. So the sent one was distorted, and then you end up receiving a 1. So the transmitter transmitted 0, it gets distorted, you get a 1. Like that. The probability is going to be, we are told it's 0.01. And then the probability now of getting a C, given C, given that it's not distorted. Remember, C is receiving a 1, B is transmitting a 1. So the probability of getting C, given it was not distorted. So meaning you receive 1 given 1 was transmitted. So that is B there. It's going to be, so there is no distortion here. So meaning we get 1 minus 0.01 for distortion. So this is going to give us 0.99. So we can receive C without distortion, and we can receive C as a result of distortion. You transmit 0, is distorted, you receive 1. Or you transmit 1, is not distorted, you receive the same 1. So we have 0.99 there. Then what are we looking for? We're looking for the probability of getting a B. Okay. Yeah, the probability of receiving, so not the B, not the B, of receiving a 1. So it will be probability of C, which are saying, okay, so it will be, you use the law of total probability here. So we have the probability of A, okay, so you transmit or multiplied by the probability of 1 received given or was transmitted plus the probability plus the probability. So now this is the first one was you transmit or you end up receiving A. You end up receiving 1 when transmitting 4. Which is the probability A multiplied by the probability C given A was distorted. The second one is the probability B multiplied by the probability C given B. So this will give us probability A is 0.6 by 0.01 plus the probability B, that is 0.4 multiplied by 0.99. That is giving us what do I have? 0.6 by 0.01 plus 0.4 by 0.99. So we get 0.402. So remember, here we're using the intersection. That's why we're describing them like this. Okay. So here I've used law of total probability.